Good. Okay, I'll finish off with some more presentation.
Alrighty. Okay.
Okay. We'll just sort of, yeah, we'll put it back behind Tony's house there.
I'm sorry.
Thank you all. Okay, it's time for a little reality check. Something I'm not really good at. But let's go to page 369. This is section 7.4, so I need to remind you that tonight's assignment is 7.3 and 7.4. So Hannah, could you read the opening key concept?
In this section, we present methods for estimating a population mean when the population standard deviation sigma is unknown.
Now, how many of you felt that we've been joking you all along when we told you that we knew what the standard deviation of the population was? We obviously just pulled that out of the thin air. We didn't know what the standard deviation of the population was. The only thing we had was a sample, agreed? We knew the standard deviation of our sample. But in order to use the z-scores, we needed to know the standard deviation of the population, so we just made one up. It's actually not as bad as that, because even though the mean weight changes with generations, for example, the mean weight of men is now quite a bit heavier than the mean weight of men 10 or 20 years ago, agreed? But the standard deviation doesn't change that much. Standard deviations are a lot more constant than means. So if we now have one from the past, then it's not too bad to keep using it. And again, we just do the best we can. The other thing that you can do is that you can make the drastic step. You say, okay, first you said it's silly because we're looking for the mean of the population. We don't know it. So we're just taking an interval and doing the best we can to predict it, but yet we say we know the standard deviation of the population. That's not consistent. But in real life, in those cases where we don't have the standard deviation of the population, what is the one standard deviation that we do have? What is it that we just got through taking? A sample. So we have that sample data, don't we? And from that sample data, we got a sample mean. And we showed what we did with the sample mean over the last 2 hours. We use it as a point estimate of the population mean, and we generate an window, an interval. But in order to do that, we had to assume a standard deviation of the population. Now, in honesty, if we don't have a standard deviation of the population, what is the one standard deviation that we do have that we might be willing to substitute for it?
Deviation of the deviation?
Of the sample. Doesn't our sample data have a standard deviation? It's the only one we've got. So whether we like it or not, we use it. And we hope that the standard deviation of our one sample is not too different of the standard deviation of the whole population. And studies support that. Even though the mean of our sample could be all over the place compared to the mean of the population, the standard deviation of samples don't tend to vary that much. So there's some support for that. Rationalization, call it if you wish. However, let's read on what we have to do. So Tony, can you read, with sigma unknown?
With sigma unknown, we use the student plus distribution instead of the normal distribution.
Okay, let's stop right there. Now, to some people, T's look like pluses, but for the rest of the world, it's a T. So we use the student T distribution. Now, as I mentioned a moment ago, if you don't know the standard deviation, you're not permitted to use the z-tables, closed book. However, we do have some tables that you can use when you substitute the sample population. These were developed for just that purpose. So let's read on and see how they were developed. So, Casey, can you assume reading, assuming that the relevant,
Assuming that the relevant requirements are satisfied. Because sigma is typically unknown in real circumstances.
let's read that one more time. Hannah, can you read those last words one more time? Because,
Because sigma is typically unknown in real circumstances.
okay, reality check, right? So we tell you the truth now. The methods of this section are realistic or practical, and they will often be used. One thing is still in effect, and that is the sample mean x bar is still the best point estimate of the population mean. In order to find out how good, we need a distribution. So we grab the only one we have, the sample distribution. If sigma is not known, but the relevant requirements are met, then we use a student T distribution. Now, the reason it's called a student T distribution is it was developed by a statistician who worked in an Irish brewery. And the brewery prohibited him from publishing. They were tight about it, a lot of companies are. So he published under a pseudonym. Well, he chose the name Student. And for a long time, it wasn't recognized who it was, but these days we know it was William Gossett. Okay. And if we turn the page, we start to get into the student T distribution, which we can use. Now the formula doesn't change very much. So look at the bottom of the next page. It says E is equal to T alpha over 2, S over the square root of N. The one that we've been using so far is that E is equal to Z alpha over 2 sigma over the square root of N. Now, what's the difference between these two formulas? First, what's the difference between these and these?
Sample versus population.
One's a sample, one's a population. So when you use the sample distribution, you can't use the z-table, you have to get T of alpha over 2. Now the T distribution is very similar to the Z distribution. The T sort of looks like that, the Z sort of looks like that. You can see the similarities. They both look like plus signs to some people, but if we look at page 374,
I probably even heard me stutter before I read it. I was like, that seems so weird. Anyway.
we're on your side. We support you. On 374, we have at the bottom of the page in the blue color. Now this discussion doesn't work so well when I use Xerox copies, but it works fine for you. In the blue color on page 374, we have the normal Z distribution, which we can't use. The T distribution is almost the same curve, is it not? It's shorter at the top, but it's higher in the wings, is it not? That's to give it more usefulness in those low numeric cases. You can use it for small numbers with much more success because it's looser in those areas than the Z distribution. But bear in mind that once you get out of the wings, you see that you will get very similar results no matter which of the two that you use. There's a large area in which they both yield the same results. So the way that you use the T distribution is as follows. The T table is very, very different from the Z table. This is how you use the T table. You need to know two things. The first is an old friend, alpha. Alpha alpha is the degree of non-confidence, agreed? What's alpha over 2? It's half the amount of non-confidence. We know those. But the other thing that you need to know to use the t-table is the number of degrees of freedom in your sample. Now, if your sample is of size n, you say, well, all of those n people are independent, so I should have n degrees of freedom. But they're not all independent, because the average value, the mean of your sample is fixed. And if the mean is fixed, then one of those persons is no longer independent in order to produce that same mean. I'll give you an example. If you have these test scores, 79 plus 80 plus 82 plus something, and 1, 2, 3, 4, and I know that their average is 81, is x free. Now x is fixed, agreed? As soon as you know the mean, then one of the members of the sample is frozen. So you have n minus 1 degrees of freedom. So the number of degrees of freedom is n minus 1. So the way that you use the t-table is first you find it. This is how you find it. Go all the way to the back of the book. These are the z-tables which you can't use. Turn one more page. Did you find the t-tables? Great. Now at the top you have alpha. The area in one tail means all of alpha, the whole thing. So you see your typical alpha values, 0.05 is 95% confidence level, agreed? 0.01 is 99% confidence level. So depending on the confidence level in your problem, you choose your column. Then you have to choose your row. You choose the correct degrees of freedom, which is n minus 1. Then at the intersection of your row and your column is the t of alpha over 2 that you're looking for. So let's try a sample problem. Page 373. Garlic. Garlic for reducing cholesterol. Blah, 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 blah. N equals 49, true? We have a sample. And the sample is n equals 49. Now, hard question. N minus 1 equals, take your time. Well done. Okay, now continue. Now, the sample mean is what? What's the sample mean? X bar is
0.4,
0.4. And what's the sample standard deviation?
21.
21. Wow. That's so strange. Okay, now, what's the confidence level?
95%.
So what's alpha? 0.05. Now, I want everyone to find for me t of alpha over 2 by using the table. T of alpha over 2. So, 0.05, 48. Get the closest one to it if you don't find one. I've got my number. Okay, now, we want the 0.05 is the total area in both tails, is it not?
Yes.
So we want to use which, the area in 2 tails or the area in 1 tails? 2 tails, because 0.05 is the sum total of the area in 2 tails. I might have said it backwards a moment ago. So with the sum total of the area in both tails is 0.05, agreed? So meaning that we want to look in the 0.05 column, and what do we find?
2.014 and 2.009.
And which is closer to 48, 45 or 50? 50, so we take 2.009. Okay? So we do the calculation. First we write the formula, 2.009. We write the formula you're going to use. E equals T alpha over 2, S over the square root of n. So E is equal to 2.009 times 21 over the square root of 49. And this is equal to 6.027. You can do that one in your head, right? So this is how you use those situations where you can't use the z-table because you only have a sample distribution. So now, how do you know when to do what? You use the flow chart. So who can find what page the flow chart is on? This is one of the best flow charts in the book. See if you can find the page. It's back in the text. Hannah, the page number is?
375.
Okay, 375. Let's locate this flow chart. You will have it on the test. Where do we start? Start. First question you ask is sigma known? What's sigma? So let's say yes, then what do we do? Ask the next question. If it's yes, then what do we do? Use the z-table. If it's no, we ask another question. What? If it's yes, what do we do? If it's no, what do? We give up. They have their own words for it. Now, let's go back to the first diamond. If is sigma not known, what do you do? Next question is? Answer yes, what do you do? Immediately use the t-distribution. If the answer is no, the next question is? If the answer is yes, you immediately use the t-distribution. If the answer is no, again, you give up. So now let's have you try some of these problems. On page 359, number 5. First, let's read the directions. So, Casey, on 379, can you read the directions to problem 5? Casey.
Using correct distribution, in exercises 5 through 12, assume that we want to construct a confidence interval using the given confidence level. Do one of the following as appropriate.
Well, let's straighten out what is a confidence interval and a confidence level. 95% is a confidence level. 60, 80 is a confidence interval, agreed? This is a confidence interval. This is a confidence level. Okay, continue please.
A, find the critical value Z alpha over 2. B, find the critical value T alpha over 2. And C, state that neither the normal nor the T distribution applies.
Now in number 1, I want you to turn back to the flow chart on 375. You're going to have to use it. So, Casey, can you lead us through number 95? Number 5.
Lead us through it.
Yes, tell us what you're going to do. Sigma's not known. Okay,
Is the population normally distributed? Yes.
so what do we do?
Use the T distribution.
And so now you have to find it. You don't just say use it, you have to get that number. What is T alpha over 2? Find it. Look it up in the table. T alpha over 2. my number.
$2.069. No?
Oops, you're probably right.
Oh, no.
21, not 22, right? My bad.
No.
Um,
No,
to
you're right.
22, no, 22, did I win one?
2.069.
Basic hammer, say yes.
Do you ever say, like, I mean, do you ever lose?
And -1.
Okay, the 23.
Good.
23 and then the.
Okay,
the
every-
details.
Everybody, do number 9. Okay, I got my answer. So is it Z or T or neither? And Z, what number?
1.645.
You notice on the Z table, they've got these little numbers in the lower right. That's the ones we're using. Shortcuts. Hello. That was worth the whole class, right? Say thank you, Tom. Okay, now the go home problem. We need you to, do this one. Number 13. Number 13. Let's read the directions. So Kelly, could you read the directions, please?
In exercises 13 and 14, use the given confidence level and sample data to find A, the margin of error, and B, the confidence interval for the population mean. Assume that the sample is a simple random sample and the population has a normal distribution.
Go. By the way, you skipped saying you. You caught up. Go home, Papa. So, we need to have 5 good copies of the whiteboards, and we're out of here. Now I'm gonna put the whiteboards far away from the camera, in the best of hopes. Ooh, Speedo.
No,
Wow.
I should do the whole problem with whiteboard.
That was impressive.
be using a T-score. Use the chart.
Is this, Sigma is unknown? I did the same thing, don't you feel
I
bad?
did too.
It's
I did the same thing.
It's the same
Not-
stuff,
can't use the
Yeah,
Z
it's
just
score.
different numbers.
Can't use the Z-score. Because it's in the section on T-scores, it's,
Yeah,
Yeah,
Kaylee had to help me out.
that
There's also the lovely flow chart.
habit,
I
Also
literally
the-
started out, like, I had the formula and everything for the Z-score, and I was like, oh wait, I don't know sigma. Like, that's what made me realize, cause I put sigma for
Alright,
the Z-score.
big time.
And I was like, oh,
big
wait.
time, that was worth the price of admission right there.
It was. That and that little cheat sheet on the, of course, you gave me that cheat sheet, I was so excited to use it, and I couldn't use it for this problem.
I forget what cheat sheet that is, someone.
At the bottom of the,
Oh, that little, yeah, down there, no, you can't use it, that's like, pure frustration. Okay, so, well done, we're out of here 3 minutes early, can't beat that.
so 2.086 was the right number?
No, her numbers are right, I
9-3.
checked them.
2.093.
9-3.
Oh,
And
minus
minus
that
one,
one?
and
Oh,
minus
yeah,
one.
yeah, yeah, N minus one, there you go, yeah. Gotcha.
I know you were,
Almost, you just have to remember n minus one.
I know you were just testing us, Freddie. Making sure we were paying attention.
Hey, what the hell's going on here?
Minus one is how you find the T-score.
I recognize that look.
You should use 19.
A level of exhaustion right now.
You still use that number, I don't know how that happened.
Get to,
Look at the draw.
um,
You probably went crooked,
I'm waiting, I did.
But N minus one is how you find the.
hopefully has been everything has been
With the T.
working, maybe
Yeah.
go to
I
bed.
think I put it on there.
Depends on what time you
Right
do
now,
it.
so I'm like, wait.
How you doing?
No problem.
I'm just gonna drink that.
Thank you.
Thanks.
Yeah.
Yeah.
Freddie, do you need a
Okay.
ride?
Huh?
You need a ride?
No, I'm stopping to see my little niece,
Alright then.
my house, Tower 118.
Did we take you again?
No, I can get right from,
But that was not me.
No, do you want me to take you then?
oh, yeah.
Wow, Fred, you got women fighting over here. What's your shoe size?
Wow,
Big
wow.
socks, right? I mean, you know what they say about big feet? Big socks.
You need big shoes.
Big shoes.
Big socks.
Oh, shoes,
It
you did
is-
that.
it
Socks is a little too
You're-
considerable.
You're
Big
easier
shoes.
to
Big
trip
shoes.
over something.
Big socks.
You did do that.
More likely to trip and fall.
Oh, my area, you know it.
Oh,
Okay,
no.
okay, good. As long as
I thought
you are
said that
aware.
too.
As long as you are knowingly making that joke.
No, I know, we're talking about the Fresh Prince, like that part.
Anybody have any Iraqi dinars they wanna sell?
No,
Any dinars
Is
they
that supposed to
picked
be
up?
back up again?
Huh?
Is that back up again?
Oh, you've been tracking what's going on with dinars or something, currency
No,
rates?
I just
No, the
remember.
dinar is like 1,300 to the dollar right now?
Everyone
1,300?
everyone said like, I don't know, it was in like 2008 or something, everyone said, oh, I'm gonna make so much money off of the dinar, and they came in and bought like thousands of dollars worth. And
But
then
they still have
sold
them,
it.
they might, they
It's very
might.
unfortunate.
How much was a dinar, back then, you know, per
I don't
dollar?
remember.
Just like 1,000 or something.
I have Rial, not dinar.
Oh,
That's
you
what
don't-
I have.
Yeah, I have Rial. I have a small collection of Rial.
Bye.
You have any, Vietnam Dong?
Enjoy
or
those.
No, I
Old
don't.
Zimbabwe Zims from 2008?
No, so.
Freddie, I'll be in the car. No, I'll
Okay.
be in the hall.
What?
I'll be in the hall.
Okay.
No, my husband collected money from his deployments and his other bases, and he was gonna get rid of it, and instead of doing that, I collected old money, so I just put it all away. So we have Won, we have Rial, we have that, it's just a collection, it's not worth anything.
I have a collection just from
It
different.
might be
It's
worth, it
different
might,
coins,
it
we
might
have
be worth something
kronar,
real soon.
we have kronar from Iceland, we have different stuff like that, we have some euros, just some old Japanese coins, it's just silly stuff, it's not, I have a 100 yen bill, look at silly stuff like that, I have a 50 yen bill. That's a thing, it's a real thing. They're supposed to be out of circulation, but I found one at an antique shop, so I got really excited and bought it.
How much was it? 50 yen? 200 yen, okay.
$5 something. I don't remember, I bought it like a year and a half ago. Need to buy some for my father-in-law. He does the same thing. He would get a kick out of it.
So Sooner or later, the US dollar bill is gonna be the same story.
What, collect it, get a kick out of it?
Collector's item,
Yeah, I got some old 20s, some old 5s, some old 10s.
yeah. We need $1,000 bill too. We'll get it soon.
We used to have a $10,000 bill.
We did?
Yes,
Treasury note or bill?
bill,
Really?
yes.
I never thought of that.
Well, it might have been a treasury bill, I don't know. Not sure, I've never seen one, I just know they exist.
Right.
Be-
Good.
Someone got
They're
one
good
as
for
a
tipping.
My husband once got one as a joke from the bank. And the bank thought he was joking, and he's like, no, I actually want it. And he got it, because it's real currency, it's just really rare. But you can take that to a bank or a car dealership and spend it, it's real money.
I'm gonna keep mine.
Yeah, he used to make a lot of money as a mechanic and construction worker before he went in the military, so. He got it as a joke one time and put it back in the bank.
Good story.